Let's see the example problem to find the critical path. A small project consists of the following activities with the time as estimates as given below. Here given the various activities along with the optimistic time, most likely time and pessimistic time. So then we have to determine the first one, draw a network. Second one, calculate average expected time for each activity. Third one, calculate the earliest expected time and latest allowable occurrence time for each event. And next fourth one is the determine the critical path. First we draw a network of the given project. So here activities 1 to 2, 1 to 3 and 1 to 4 are starts from the event 1. So draw these activities like this. So 1 to 2, 1 to 3 and 1 to 4. Next activities are the 2 to 5 and 3 to 5. So for these activities, event 5 is the merge event. So draw these activities like this. So these are the activities 2 to 5 and the 3 to 5. And next one is the activities 4 to 6 and the 5 to 6. For these activities, event 6 is the merge event. So draw the activities 4 to 6 and 5 to 6 like this. So this is the network diagram of the given project. Next question is calculate average expected time for each activity. We know that expected time TE equal to the T0 plus 4Tm plus TP divided by 6. Here T0 is the optimistic time, Tm is the most likely time and TP is the pessimistic time. So TE for the activity 1 to 2 which is equal to the 2 plus 4 into 2 plus 14 divided by 6 which is equal to the 4. Next for the activity 1 to 3. So TE equal to the 2 plus 4 into 8 plus 14 divided by 6 which is equal to the 8. Next for activity 1 to 4. 4 plus 4 into 4 plus 16 divided by 6 which is equal to the 6. Next for the activity 2 to 5. So 2 plus 4 into 2 plus 2 divided by 6 which is equal to the 2. Next for the activity 3 to 5, TE equal to the 4 plus 4 into 10 plus 28 divided by 6 which is equal to 12. Next for activity 4 to 6. So TE equal to the 4 plus 4 into 10 plus 16 divided by 6 which is equal to 10. And last activity 5 to 6. TE equal to the 6 plus 4 into 12 plus 30 divided by 6 which is equal to the 14. So these are the expected time for the each activity. Then we have to represent this expected time on the respected activity. So for activity 1 to 2, TE value is the 4. And for the activity 1 to 3, 8 and 1 to 4, 6 and 2 to 5, 2. 3 to 5 is 12 and the 4 to 6, 10 and 5 to 6 is the 14. Next question is calculate the earliest expected time and latest allowable occurrence time for each event. So have to calculate the earliest and latest time by forward pass and backward pass method. First to apply the forward pass method to determine the earliest time. For forward pass method, always have to start at the starting event and consider starting time is the 0. So here starting event is the 1 and considering its earliest start time is the 0. Next for the activity 1 to 2, start at event 1 which is 0 and end at event 2 which is equal to the 0 plus estimated time that is the 4. So 0 plus 4 which is equal to the 4. So for activity 1 to 2, earliest start time is the 0 and earliest finish time is the 4. Next for the activity 1 to 3, start at event 1 which is 0 and end at event 3 which is the 0 plus 8 which is equal to the 8. Next for the activity 1 to 4, start at the event 1 which is 0 and end at the event 4 which is the 0 plus 6 which is equal to the 6. So next activity is the 2 to 5, start at the event 2 which is the 4 and end at the event 5 which is the 4 plus 2 which is equal to the 6. So here observe, event 5 is the merge event for the activities 2 to 5, 3 to 5. So we have to consider the finish time is the maximum finish time of activities 2 to 5 and 3 to 5. For the finish time, activity 2 to 5 is the 6. Next we have to look for the finish time for the activity 3 to 5. So for the 3 to 5, starting time is the 8 at the event to 3 and the finish time is the 8 plus 12 which is equal to the 20. Among the 6 and 20, maximum is the 20. So we have to consider the earliest finish time at event 5 is the 20. So next we have to look for the activity 4 to 6. So start at the event 4 which is the 6 and end at the event 6 which is equal to the 6 plus 10 which is equal to 16. Here also event 6 is the merge event for the activities 4 to 6 and 5 to 6. So we have to consider the finish time is the maximum finish time of activities 4 to 6 and 5 to 6. For the 4 to 6, so finish time is the 16. And next we have to look for the activity 5 to 6. For activity 5 to 6, so starting is at the event 5 that is the 20 and finish time is the 20 plus 14 34 at the event 6. So which is the 34. Among the 34 and 16, maximum time we are considering as the earliest finish time. So that is the maximum is the 34. So have to consider the 34 is the finish time at the event 6. Next to apply the backward pass method to determine the latest time. For the backward pass method, start at the end event that is the event 6 and finish time is the 34. So next for activity 5 to 6, finish time is 34 at the event 6 and start time will become the 34 minus 14 which is equal to the 20 at event 5. So next one is the activity 4 to 6. Finish time is the 34 at the event 6 and start time will become the 34 minus 10 which is equal to the 24 at the event 4. And next for the activity 3 to 5. So for the activity 3 to 5, finish time is the 20 at the event 5. Then start time will become the 20 minus 12 which is equal to the 8 at the event 3. So next we have to look for the activity 2 to 5. Finish time is 20 at event 5. Then 20 minus 2 which is equal to the 18. 18 is the start time for the event 2. So next activity 1 to 4. So for activity 1 to 4, 24 is the latest finish time at the event 4. Then latest start time is the 24 minus 6 which is equal to the 18. So here observe, event 1 is the burst event for the activities 1 to 2, 1 to 3 and 1 to 4. So latest start time at event 1 is the minimum of the starting time of the activities 1 to 2, 1 to 3 and 1 to 4. So for the activity 1 to 4, so start time is the 18. Next we have to look for the activity 1 to 3. So for the activity 1 to 3, so finish time is 8 at the event 3 and start time will become the 8 minus 8 which is equal to the 0. So next for the activity 1 to 2, so 18 is the finish time at event 2. Then start time will become the 18 minus 4 which is equal to the 14. So latest start time at event 1 is the minimum of the 0, 14 and 18. Among these three, minimum value is the 0. Next we calculate the earliest start time, earliest finish time and latest start time, latest finish time. For this we have to draw the following table. Here first column is the activity and next column is the normal time or the estimated time. Next one is the earliest start time ES and next column earliest finish time EF, which is equal to the ES plus time duration. And next one is the latest start time LS, which is equal to the latest finish time minus normal time. And last column is the latest finish time, which is the LF. So first we have to write down the earliest start time by observing the network diagram, which is calculated by the forward pass method. For the activity 1 to 2, earliest start time is the 0 at the event 1. Similarly, for the activity 1 to 3 and 1 to 4, earliest start time is the 0 at the event 1. Next for the activity 2 to 5. So for the activity 2 to 5, earliest start time is the 4 at event 2. Next for the activity 3 to 5, earliest start time is the 8 at the event 3. Next for the activity 4 to 6, earliest start time is the 6 at the event 4. And next for the activity 5 to 6, earliest start time is the 20 at the event 5. So next we have to calculate the earliest finish time, which is equal to the earliest start time. We know the earliest start time values plus time duration or the normal time. So for the activity 1 to 2, earliest finish time is the earliest start time 0 plus normal time is the 4. So 0 plus 4, which is equal to the 4. So for next for the activity 1 to 3, so 0 plus 8, which is equal to the 8. Next for the activity 1 to 4, 0 plus 6, which is equal to the 6. Next for the activity 2 to 5, so 4 plus 2, which is equal to the 6. Next for the activity 3 to 5, 8 plus 12, which is equal to the 20. Next to activity 4 to 6, so 6 plus 10, which is equal to the 16. And next for the activity 5 to 6, so 20 plus 14, which is equal to the 34. Okay, so next we have to calculate the latest finish time. So by observing the network diagram, which is we determined by the backward pass method. So first we have to write down the latest finish time for activity 1 to 2. So for the activity 1 to 2, latest finish time is the 18 at the event 2. Next for the activity 1 to 3. So for the activity 1 to 3, latest finish time is the 8 at the event 3. Next one is the activity 1 to 4. For activity 1 to 4, so latest finish time is 24 at the event 4. And next for the 2 to 5, so for the 2 to 5, latest finish time is the 20 at event 5. And next for the 3 to 5, same 3 to 5 also, latest finish time is 20 at event 5. And next one is the event 4 to 6. For event 4 to 6, latest finish time is 34 at the event 6. Similarly, event 5 to 6 also, latest finish time is the 34. So next to calculate the latest start time, which is equal to the latest finish time minus normal time. For activity 1 to 2, so latest finish time is the 18, so minus, so normal time is the 4, so 18 minus 4, which is equal to the 14. Next for the activity 1 to 3, So latest finish time is the 8 and normal time also 8. So 8 minus 8 which is equal to the 0. So next for the 1 to 4. So 24 minus 6 which is equal to the 18. Next for the activity 2 to 5. So which is equal to the 20 minus 2 which is equal to the 18. Next for the 3 to 5. So 20 minus 12 which is equal to the 8. And next for the activity 4 to 6. So 34 minus 10 which is equal to the 24. Next for the activity 5 to 6. So 34 minus 14 which is equal to the 20. So these are the earliest start time, earliest finish time, and the latest start time and latest finish time. Next question is determine the critical path. For this one, first we have to identify the critical activities. We know that for the critical activities, total float equal to the 0. So first we have to determine the total float of the each activity. Then we have to identify the critical activities. So total float equal to the latest start time minus earliest start time. For the activity 1 to 2, latest start time is the 14 and the earliest start time is the 0. So total float is the 14 minus 0 which is equal to the 14. For the activity 1 to 3, latest start time is the 0 and the earliest start time also the 0. So 0 minus 0 which is equal to the 0. Next for the activity 1 to 4, latest start time is 18 and the earliest start time is the 0. So 18 minus 0 which is the 18. So total float for the activity 1 to 4 is the 18. So next for the activity 2 to 5. So which is the latest start time is 20 and the earliest start time is the 4. So 20 minus 4 which is equal to the 16. So next for the activity 3 to 5. So latest start time is 8 and the earliest start time is 8. So 8 minus 8 which is equal to the 0. Next for the activity 4 to 6. Latest start time is 24 and the earliest start time is the 6. So 24 minus 6 which is equal to the 18. Next for the activity 5 to 6. So latest start time is the 20 and earliest start time is the 20. So 20 minus 20. So total float equal to the 0. So here for the activities 1 to 3 and 3 to 5 and 5 to 6. These are the critical activities because of the total float is 0. So from the above the table, we observe the activities 1 to 3, 3 to 5, 5 to 6 are the critical activities and the critical path is 1, 2, 3, 5. So this is the critical path. And this critical path is we have to draw in the network diagram. So by drawing the double arrows. So 1 to 3, 3 to 5 and 5 to 6. These are the critical activities and critical path is the 1 to 3, 3 to 5 and 5 to 6. So 1, 3, 5, 6. So 1, 3, 5, 6 is the critical path. So time duration is the 1 to 3 time duration is the 8 plus 3 to 5 which is the 12 and 5 to 6 which is the 14. So 8 plus 12 plus 14 which is equal to the 34. So duration of the project is the 34 months. This is the solution and thank you.